Morning friends, we already started current electricity. It's a third chapter from your syllabus. Ohm's law we have discussed. V is equal to IR. It's a Ohm's law, and dependence of resistance on length and area of cross section gives us a new concept of specific resistivity. Now what is the cause for resistance? And in this topic we are going to discuss why the conductor offers resistance. The cause for resistance is the collision of electrons with the ions. And then we are going to discuss drift velocity and origin of resistivity in this one. Two things, it's a drift velocity. Second one, origin of resistivity. Now, one conductor we consider. There is a conductor. Inside this conductor, you all know, there are positive ions and free electrons. Free electrons can move within the conductor itself. So these free electrons, they collide with the ions there. Free electrons, they collide with fixed ions. Fixed ions. After collision, the electrons do not change their speed. They emerge out with the same velocity, but their direction changes. So, the velocity remains same after collision, but only the direction is changing. So, in this one, there is a constant change in direction of the electron. They move with random directions. Suppose that there are n number of electrons and V1, V2, V3, so on, Vn are the velocities of different electrons. Then average velocity V is equal to V1 plus V2 plus so on Vn divided by n, which is given by Vn summation Vi. I goes from 1 to n. This average value is equal to 0 as the electrons are randomly moving, but their speed does not change, only their direction changing. So average value of velocity is equal to 0. Now suppose that electric field is applied to the conductor. To this conductor, electric field is applied. We all know there is force due to electric field F is equal to QE, which is equal to minus E into E. E is a charge on electron and capital E is electric intensity. According to Newton's law, force is equal to M into A. Therefore, MA is equal to minus E, which gives us E is equal to. So this is the acceleration when the field is applied to the conductor. As soon as we apply electric field to the conductor, the acceleration on the electron is equal to minus E by M, where E is a charge on electron, capital E is electric field, M is mass of electron. Now let us see what happens. Suppose that this electron is colliding randomly. These are two collisions. This is the last collision. So, between these two collisions, time t is there. At time t. So, this is called as time of collision. Now, after that, there is ti. After last collision, there is a time ti, which is called as time lapsed. This is known as time lapsed after last collision. Now this is Ti, but then we can go for relaxation time also. Relaxation time, tau is average time after last collision for n number of electrons. Relaxation time, once again I define, average time after last collision for n number of electron, we call it as relaxation time. Now, naturally, when it is accelerated, this is v plus minus E by m, and this is Ti for one electron. Velocity thereafter. First kinematical equation we can use. You all know v is equal to u plus At. This is before, smaller one I am using. This is acceleration. Suppose that there are n number of electrons and we want to take average. So we write it as V average is equal to V average for n number of electrons. Vi, there is plus minus E m by Ti average. We have taken average. Average means summation in this one. Now this V average, without electric field, this becomes 0. This is again V average for all. This is minus E by m and average. This average value is known as 2, relaxation time. Ti average we define it as. Therefore, this V average is equal to minus m2. Check it here. This velocity is independent of time even though the electrons are accelerated. This is important thing. If electrons are accelerated, then it should be time dependent. But here we get it. The velocity is time independent even though the electrons are accelerated. Such type of velocity we call it as a drift velocity. So here we come for the drift velocity. What is the meaning of drift velocity? Vd is equal to minus capital E by m2. This is called as drift because it is independent of time even though accelerated. So drift velocity we can define the velocity independent of time even though the electron is accelerated. Now again consider this one. If this is L and V is the velocity of this one, so we can say that this L is Vd delta t. Within time delta t, it will take this much distance. Now all the electrons, they will cross this distance within this delta t. Let us consider n, number density. What is n? Number density of electron. Number density is nothing but number of electrons per unit volume. Number of electrons per unit volume, we take it as number density. Okay, total number of electrons. N number of electrons are n into volume. N into volume will be, if A is area of cross section, volume will be A into L, which is equal to A Vd delta T. This is total number of electrons. Total charge on these electrons, Q is equal to minus Ne, minus E and A Vd delta T. Current is equal to charge by time, which is equal to minus E and A Vd delta T. Time here is a delta T. Therefore, current is equal to Na Vd. Already Vd we have derived there. Vd is equal to minus E m into 2. This is Vd. So current I is equal to, we can replace it. Minus it becomes E square A 2 by m. This is the current. where N is number density, E is a charge on electron, A is area of cross section, Rho is relaxation time, M is mass of electron, E is intensity of field. We also know I by E is equal to NE square, Rho by M E. We all know I by A is J, which is equal to NE square, Rho M E. And then there is a Ohm's law in vector form. It suggests J is equal to sigma E. It gives us conductivity is equal to NE square tau. Conductivity, this is sigma is known as conductivity. Conductivity is equal to NE square tau by M. From this one, sigma is directly proportional to 2. As temperature increases, this explains temperature dependence also. So sigma depends on this tau, and tau it depends on drift velocity. So origin of resistivity is nothing but except drift velocity. Now let us discuss about temperature. Suppose that temperature is increasing. When temperature increases, tau decreases because of more number of collisions. Relaxation time decreases because the number of collisions are increasing. And as soon as tau decreases, sigma will decrease. So in case of conductor, when temperature is increasing, resistance decreases. When temperature is decreasing, resistance increasing. That's all for this. Thank you.